thought I'd start with something upbeat. Someone said to me at some point today that in educational neuroscience, a very worthy topic, but there's an element of self-flagellation about it, that we're immensely self-critical about all the things that we're doing wrong. So I think our enterprise is a positive one, and we should think about, let's improve education. We can do it. This is about the future. So let's be a little bit positive. I've been sitting at the back all day, and I've been playing a sort of game like Countdown, where I've been trying to summarize each speaker's talk in fewer words than their own title. So I don't know how well I've done it, but this is the story so far. So we started off with Daphne talking to us about action video games and that they might improve attentional control, and then some discussion about how wide the improvements might be to what other educational skills. We heard from Denis a case study of starting off with some neuroscience findings and trying to actually translate those into a technique that works in the classroom, looking at science and maths, and that technique is currently under evaluation. We then heard from Kate about the practical barriers that are in place for trying to improve teaching and how teachers reflect on their own teaching and try and improve their practices. Then we had a keynote from Paul. He went into some detail about the current evidence from educational neuroscience about what works and how detailed that evidence is in various areas in maths and reasoning, reading and so forth, and what the distance of there was from that research to application. And Paul also raised some questions about the right models of translation and how to evaluate that. And particularly we heard some discussion about randomized controlled trials and whether they were the appropriate ways to evaluate teaching techniques. Then Alice talked to us about subtypes of executive dysfunction and how these are children with behavioral problems of various sorts and how they might be diverse in the underlying causes and how that might point to different models of behavioral change depending on the subtypes. And then Tara gave us a very passionate example about how you actually do that, how you take that kind of indication from research and actually change the structures, practices in a school and some of the inertia in the staff members and the structure of the school day to try and take those findings and yield what sounds to be very positive results. Leona then talked to us about the leadership challenge of going from, I couldn't fit the that bit on there, but the what and the how of learning and trying to use that accumulating knowledge to produce change in the system. And then finally, Judith gave us a more kind of detailed example on the ground in the context of a particular school about leadership to improve teacher knowledge and implementation of practice. There you go, that was a whole day. Could have just come to this bit, would have saved you some time. Okay, so a few comments from me. First of all, I want to point out how current the use of neuroscience is, even at the highest levels. Now, you may remember this guy, face looks familiar, used to be the Prime Minister, and David Cameron was very interested in kind of the same work that Tony Blair was interested in the educational outcomes for children at the bottom end of society and the inequalities in the education system. And he was about to launch his, life chances strategy. And this was a speech he gave back in January 2016. If you put in the life chances strategy, I think you only get 2 hits on Google. And one of them is this. And then another one is a select committee, which was convened to evaluate this policy. And that took place in July of last year. But this is just a little excerpt from the speech that David Cameron says, when neuroscience shows us the pivotal importance of the first few years of life in determining the adults we become, we must think much more radically about improving family life in the early years. And it's a long speech, a detailed kind of policy statement that if you read it, at many points it refers to neuroscience evidence. So that indication that right now neuroscience evidence is filtering up to the highest level of policy. Now, the Life Chances strategy was due to launch on June the 24th. If anyone knows what happened on June the 23rd, raise your hand. So, unfortunately, it disappeared. It was never launched. It may reappear in some other format under the new, I was going to say regime. That would be wrong, wouldn't it? Government. Okay. So, I was sitting at the back trying to make some sense. So many kind of messages, all of them sounded important, and trying to put them into some coherent shape. And I thought it was probably important to try and distinguish between different levels. So certainly there's a systems level, and we heard more about that right towards the end, about how do you change actual structures of the education system within a country. And then there's down at the individual level about classroom practice, what teachers know, how they're trained, what they do in the classroom. And then from the neuroscience perspective, something about the learning mechanisms, the properties of children, how they respond to in various educational contexts. So I've been trying to distinguish in my head between those levels, and then think about how evidence can inform any one of those, and what the different types of evidence would be. And we saw a discussion today about evidence. There's different types of evidence. What is the right type of evidence at each level to inform each of these levels of description, what we should be doing to improve education. So I've stolen some content from another very entertaining speaker, much more entertaining than me. If you've been to, this guy's called Pasi Sahlberg. He's an expert in education from Finland. Finland is where they've cracked it. They understand how to do education. They're best in the PISA. See what I did there? Best in the PISA results. And I went to one of his talks, and he had the whole audience singing "Knock, Knock, Knocking on Heaven's Door." I'm not going to be doing that with you today. I don't have those kind of talents. But so one of the things he was talking about is from a systems level, you can compare across different countries and look at their different education systems and have a look about, in a fairly simplistic way, about how those correspond to PISA results in maths and science and languages and so forth. And this is one of the slides from his talk about, these were 4 myths of quality teaching from the systems level. And he argued that these are the things that don't improve educational outcomes: competition between schools, standardization of teacher practice and what learners are doing across schools, standardized testing linked to accountability. You apply standardized tests, and then you reward or punish schools based on the scores on those standardized tests. And then the idea that somehow kids now, because they're using tablets and everything, that they're much better learners than people were previously. So that's a kind of approach. Now you have to look at Pasi Sahlberg's own books for the evidence supporting all that, but it's an indication of how you might collect evidence at the systems level. I'll also steal one of his slides for looking at the individual level. And he said, we do know quite a lot about teaching practices at the individual level about what is quality learning. We know it involves active construction from the learner rather than passive absorption. We know that it's a process of accumulation, that children link new knowledge to old knowledge, that involves self-regulation. The best learning is where learners are in control of their learning and understand something about their own processes of learning, and that it's a process of cooperation. So learning happens in interactions between individuals involving communication and helping and explaining and so forth. And I think it's interesting here that this was a quote that Pasi Sahlberg put up that he found very influential. The most important single factor influencing learning is what the learner already knows. Ascertain this and teach him or her accordingly. I think I would add to that, from something about what we've heard today, that you also need to ascertain how the individual, how the child will respond to being taught. I think it's not just enough to know what they know, to find out what they know already, but when you put them in teaching situations of a certain sort, how they will respond, because that, as we've seen, can differ across children. So there's something there about the teacher needs to know something about their kids, and it needs to be, the teaching practices may need to be differentiated across the different children. Now, I think there are problems, even if you're just looking at evidence on teaching. I saw one review paper that said psychologists have been working for 125 years accumulating studies about how memory works. And there are still many myths in teaching that go against that evidence. So one example is that practicing rote memorization improves anything general about learning. So there's still this view that learn to memorize poetry and recite it. And then if you do a lot of that, you'll be a better learner. Whereas actually a lot of evidence shows that what that improves is your ability to recite poetry. So there are these, even forgetting neuroscience, even when there's a big evidence base, actually getting that to translate into practice is always a challenge. Okay, so if we go down to that bottom level about mechanisms, I'm not going to talk much about neuroscience in this closing thing. I think you've had enough neuroscience. All right, there's some brains coming up. But I think the important question is, what do teachers need to know about all this neuroscience? It's a question that's come up several times today. Do we need teachers to be like kind of researchers in neuroscience, reading the latest papers that are coming out in Nature and understanding the methods and the treatment of detailed evidence and so forth? And I guess most of us would think probably not. But then what is it that teachers do need to know about neural mechanisms? And my guess is it's, okay, I'm waving my hand a bit, kinda how the brain works. And kinda how brains differ between individuals, and then starting points of different techniques for teaching given the preceding knowledge. And I think this is important because it goes against the idea of randomized control trials that create prescriptive treatments, the kind of things that Paul was talking about. Because teachers want to interact in the situation, they want starting points and lesson plans, but they need to be able to tailor them to their own skills and the particular children that they have in front of them in the context of their own school. So the kind of things we need to convey are gist of function, principles of function, not individuals must sit down and do this particular behavior in this way, otherwise they won't learn. That's my guess about what teachers need to know. I thought it was a very nice example when Tara talked about taking the kind of cognitive neuroscience evidence that Alice presented and then trying to translate it into what does that mean about how they teach and respond to kids with different needs. Okay. And when Tara was talking, she wasn't talking about brain areas. She wasn't talking about the nuclear accumbens and the basal ganglia and so forth. It was just this idea that this behavioral regulation, punishment, reward, empathy, these kind of notions are important in understanding techniques, but you can understand their relative importance by understanding neuroscience principles. So I think that's an indication of, I think, about one of the ways that translation will work is about conveying to teachers the gist of function. Of course, when I talk about you need to know kind of how the brain works. Whose brain are we talking about? I heard a lot about children's brains, but let's start off with your brains. How do your brains work? Well, we're hoping you got something from today. So I was just jotting down, I think, what parts of your brain were working. It should be episodic memory, so you remember what happened today. And then you want to transfer that into conceptual memory, so the kind of knowledge and ideas, and then some sort of planning for activities, prospective memory, that's kind of a prefrontal thing. And then you want to engender future behavior and institutional change, right? So you as audience members, something needs to be going on in your brain plasticity, in order to get something from today. I said I put brains up. I think it's a little bit more serious about, I think there's still work to do from a cognitive neuroscience perspective to give teachers the right gist about brain function in children and young adults. And I still think that the message out there and the understanding of things like there's a general thing called working memory. And the faster your brain goes, the cleverer you are. There's still ideas out there which are not really sufficiently influenced by what we understand about the brain. What we understand about the brain is that mostly it's using specialized circuits for particular tasks. And that's why, on the whole, when you practice a task, it's those circuits that get better, and other skills using different circuits don't improve. That's why, on the whole, you don't get techniques which make you better at everything. However, in a system that works like that with specialized systems, you need to coordinate those systems using a control system that says you should be on, you should be off, and bear in mind what we're doing here. That's the prefrontal cortex. That type of system, if you train that up, that might have more kind of general task engagement improvements. So it's a system with specialized circuits that works with activation and inhibition. It doesn't really like to abstract. You know, we have to work hard to put these kind of logical, formal reasoning concepts and principles of maths and science and all, have to put people in particular circumstances and use language to manipulate their knowledge in particular ways. It's not the automatic response of the human brain. We have to remember that this system is proactive. It's an agent that wants to exert control, and if it feels out of control, it won't be a happy learner. And we have to bear in mind that this is a social primate. If you look at the emotional circuits of the brain, they look pretty similar to what you see in a chimpanzee. So there's many aspects of our dominance hierarchies, our attachment behavior, our peer relationships and so forth that are quite general across primates and aren't particularly special to humans. Much bigger neocortex, and part of that is the prefrontal cortex, enabling us to do control, much more complicated communication system. But in some respects, we are just social primates. And this question about plasticity and the fact that most of what we're trying to do in education is give people culturally specific skills that we invented, that their brains quite often resist. That's why it's taking 5 years to teach kids maths. Whereas there are many skills that they're learning just through natural exposure in the first few years of their life. Okay, so a lot of the time we focus on students, and it was mentioned today that we often don't focus on teachers, the teacher's brain. What will make you a good teacher? What kind of brain do you need? These are probably some of the things. Obviously, you need domain knowledge, perhaps mastery, expertise. We heard a little bit about that. Clearly, some set of schemas and procedures. When you're in this situation, you need to do this. Perspective taking, some of these social neuroscience ideas of being able to twist your point of view to what the student is hearing. Social perception, to pick up facial cues, postural cues about what your students are feeling at that time. Empathy, your ability as a teacher to self-regulate, to remain calm, to guide pupils back to your lesson plan or respond flexibly to change it. Metacognition, understanding of your own strengths and weaknesses. And then I put tap dancing at the end, often comes in handy on a Friday afternoon where you may need to keep everyone entertained. Okay, so I should say, my guess is the way educational neuroscience is pointing is that there are big gains through changing factors of the environment and the educational system when things are going wrong. So particularly in cases of deprivation or poverty, malnutrition, cases of limiting developmental disorders, we can get big gains. But once we've eliminated those cases, probably thereafter improvements will be the accumulation of many small effects. Okay. Tailoring lessons in a certain way, making sure the environment is noise-free and has the right kind of resources, and making sure everyone's fit and healthy, engaged, and so forth. Each of these may just add a small gain. And I think we probably have to bear that in mind when we evaluate the effectiveness of various techniques, that we may shortly be looking at quite small effect sizes that are hard to individually detect, but you put them all together, you might get a big gain. We did hear right at the start today about video games, and I think this still reflects a desire out there that we can find these special, maybe surprising techniques that will make us all better. Okay? And maybe there are some of these things out there. I list some of the ones that there's a lot of research around. I'm just pointing out there's a lot of research around them because it would be great if we could find these kind of amazing effects that make you better at everything. As to how effective each of them are, in many cases, the jury is out. But we do want to find these things. They may not be out there. We may be looking at many, many small gains with small effects. Okay, and no one ever said it was going to be easy. And this is where life is tough as a neuroscientist. And I'm going to show you quite how tough it is. So learning, that's educators, that's easy, right? Learning. Psychologists, still quite easy. One word. This is what learning looks like to a neuroscientist. It's, I don't know, half a dozen different local mechanisms of synaptic growth, myelination, axonal arbor changes, dendritic tree growth, neuromodulation, cellular body resting, excited, and so forth. No new neurons, but there you go. Systems function, we have classical conditioning, operant conditioning, modeling, episodic memory, reward-based learning, sensory motor statistical learning, cross-modal mapping, sequential procedural learning, prediction, automation, verbal instruction, verbally driven analogy-based learning. So it's going to be hard to figure out from the brain's perspective how we map to these concepts which seem kind of unitary at the psychological level, at the individual level, at the educational level. But that doesn't mean it can't be done. And there's a very large number of researchers trying to progress understanding at that level. And of course, I never said it was going to be easy. That's just learning mechanisms. And we all know that education is not just about learning, but there are indeed many other factors involved in the education system and changing its trajectory. I'm going to finish with a shameless plug. I too am involved in the Unlock project. We are recruiting schools for this science and maths intervention. If you're interested, please visit the website, please get in touch, and thanks for your attention.